Right folks, here we're going to have a little look at 2019 question 4. Nice little bit of a developments question and even a little bit of solids and contact here. Okay, so having a quick look at this, what do we see? Alright, we've got to draw the given elevation and plan, development of the conical surface A, and semicircular handle. Okay, so great, no end views, no bits and pieces like that. So what I'd suggest to you is just draw this to either one side or the other of the page. So I'm just going to draw it here in the page and leave a little bit of space here to get my developments done. Okay, so first things first, I would say we always want to start in these questions with what? Okay, it's going to be the circles. So for instance, R35 is that top edge, so I'll draw that here, I'll project it up. Then I'm not given the bottom diameter, so I need to use the angle to come down. That's fine. Again, R30, that's okay, but I don't know where this touches, so I have a little bit of an issue to figure this one out. All right, so let's start with what we can do. And we definitely have a bit of fun to be done here. Alrighty. Now, so we'll just do our XY there. You can see this nicely. Good stuff. And I guess we need to pick a place to start, really. So, this looks like it'll leave me loads of room, so we'll just decide that is going to be where it goes. And we're told how far down, we're not, so we'll just leave a 20mm gap. 35 plus 20, 55. It's down by 55. Okay. There we go. And we'll just do a little construction line here because it's much easier to find things when we have the construction line. And we'll probably find we're going to need it for something anyway. Okie dokies, that's that. Let's go get our 35 drawn. Okay, so looking at this, it is going to be a heavy line, okay, the whole way around, okay, because as we're looking down, we see the whole top of it. So we can just draw this in nice and heavy straight up. And just a couple passes. Again, this stage you all know how to use your compasses. We should only be holding them with the top of it. Okay, what do we know next? Well, let's send this guy up. Do we know how tall it is? Oh, we do, 70. Excellent. Let's mark off our 70 height here. And I'll just give it a little construction line going across there. And we'll send this chap up. Okay, so there is my top edge. And looking at the drawing again, I can see that also will be a heavy line because we can see that whole top edge. So we'll pop it in there. Okay, so we are given an angle here, 75 degrees. So let's grab the old protractor. Okay, that's 75 like that. So let's pop this in here. And again, make sure it's lined up nicely there. That's 70, that's 80, so that's 75 right there. And it's quite nice. It's actually, we can use the protractor to get the edge of that. That's going to be a heavy edge. We'll do the same over here, but actually I'm not going to remeasure that one. Now, it's not just because I hate protractors and I don't like using them. It's actually to try and make this a bit more accurate. So what we'll do is we'll bring this down here. Okay, and this will allow me to get the bottom. Now it's a bucket, so that's why we can see this heavy. So what I'm going to do is I'm going to take this, draw in the bottom of the bucket like that. We see where this is going now. And of course we'll project back up, and this just means it's bang on the right size in case that was something off, you know, 74 degrees or whatever. Everything just lines up neatly. Now this one, we do have something going on this side, so I'm only going to put it in as a light construction. There we go. Okay. Now, what else have we got on this that we can do? Well, we'll put this little line here, this hoop, stick that guy in there. There we are. Now, let's see, can we get the top of this? And this is actually a really nice little bit of a construction here. So we essentially want to, you know, if we look at this, it's a semicircular hoop. So it's just a semicircle view it this way, which is pretty easy, but of course it's awkward when we have to look at it this way. So what we're going to do is, well, either we can change the way we look and look at it that way, do an auxiliary view, but that's kind of a nuisance, especially at junior cert level. So we're just going to rotate this guy. We'll pop it in here, we'll see where it is, that'll be a semicircle, and we'll just put it back. So that's not so bad to do. And actually, we could go to the ball of rotating, but you can see it is going to literally be the outer diameter there. So we'll just pick up that diameter. It's like it's rotated down, and this is the construction of it. Around. Now, we need to get a couple of points. Well, the center hasn't moved, so that's going to be right there. But maybe if we had 2 other points on this one, we can see where they are. Now here's how I'm going to get those points, and you might see a connection with this to something else we do. If we want to get 2 random points, let's just do it with pizza slices. I'll do an axial symmetry on the other side. No need to do loads of constructions. So that's where that point was in the rotated position. So let's send it down. And we'll use a couple of little colors here. So the orange dots can be where it was rotated, which is there, and we'll send it back. So remember, we had one that was there here, and we can see where this is going to go. So just get a pencil. So this outer one here just rotates up to there. That's fairly straightforward. Okay, you can see it's the same on the other side. So I have those points. Now what about this point? Well, it was there. Let's rotate it back. There we go. We lost a bit of light there. There, that's a bit easier to see now. Okay, that should be a bit better. So it was there. Rotate it back to where we wanted it to be. Okay, so the green points is where they really are. That's of course a green one now. And let's send it up. Okay, well, how far up does it go? Well, when we spin it back in, this guy just goes across. So from this one, it just comes across like that. And it comes up, up, up along here. And the point ends up being there. Now you may see a bit of a similarity here, because this is essentially our circle construction for an ellipse. All right, slice, cross, up. Okay, so it gives you a little bit of an idea where this comes from. We'll do the same for the other point. That's it there. And of course, you could have gone straight into a circular construction for the ellipse, realizing that that's the minor axis. You'd have gotten the same thing. Okay, so that point is there. Spin it up. Okay, so it's just outside that inner diameter. There we go. Up it comes. Of course, we bring it all the way up. And then across. And that's where that point ends up being now. Of course, to get the 2 on the other side, we'll just bring these straight across and do an axial symmetry. You got to repeat the whole construction again, but this is a bit faster. Let's bring that line a little bit further. There we go. Okay, we've gone a tiny bit off camera there. So, cross like this. And there is that little ellipse at the top. So you can see how it actually connects to our circle construction that we'd normally use. In case you ever wondered where that really came from. And down we go this side. Alright, and if you hadn't spotted any of that, you might have just realized that that's the minor axis there to there. You could draw another little circle and you would have gotten exactly the same thing. Okay, so where to next? Now, we've got that done, Let's go back and look at our question. Well, we need to put B in here. So we know B is radius 30. Now this again is an awkward problem to solve. So the first thing we know about it, well, we know the center is going to be 30 off the ground. So we can put a little line in for that. Let's just measure up 30. I'll just make a mark on this line and across there. So somewhere along that line is the center. So if I can just figure out where along it, I'm sorted. What we'll do, well, the thing is, if I looked at it this way, I'd see where these are touching. Okay, so I'd know that the center here is 30 away from the edge and where it slopes in underneath. So what we're going to do is we're going to turn them. So instead of them being like this, see if you can see this on my glass here and there, I'm going to rotate it back like that, because then in the elevation I can see the edge, which I would show you, except it'll sort of tip my water out. There we go. Alright, so that's how we're going to try and solve this. And this is actually straight off, you see this as a DCG question quite a lot. Okay, well what are we going to do? So we're going to draw a line in an easier position, which would be here, and then we'll put it back. So let's go 30 away from the edge. And remember, there's a lovely little trick to do this here. So I want to move this guy 30 from the edge. So what we'll do is we'll line this up with the edge. See it there? And of course line it up again, but it's all right. And then we will line up our 10 with the 0. See right there, the 10 and the 0. Okay, basically it's hard to see this edge. It's very easy to see the 0 line. The 10 is in the middle, so I'm not going to get the thing sliding around to me. So now if I move this by 30, well, it hasn't changed shape. So if this is moved by 30, then this is moved by 30. And there we are. Okay, let me just check that because it doesn't look as parallel as could be. Yep, there we go. So that there is our center. Okay, so that was 30 away. So that allows us to draw the ball. We don't have to actually draw this construction, but I'll draw it to show you now. Okay. So that's kind of where it would be in the easier position. Just see if you can see that correctly on camera. Yeah, it's a little bit light. I'll just sketch it in orange so you can see it. Now, all we actually need to know from this one is really where the center is. So you wouldn't have to draw the outside, but this is just to explain what's going on here. Okay. So now that we know where our center is, well, let's see if we can put that back. So we'll project it down. Now, if we're seeing it in the rotated position, the center will be there. Are we given any information about where it is? We are. We know it's in line with the 45. So we'll get a 45. So the center is somewhere along that line. And of course, if we're going to spin it back into place, we're just going to pop our compass into the center. And there it is. So there's our center. Remember, we used the green for the rotate ones back in the real position, and that's it there. Okay, so rescue our pencil here. And now, of course, I can project back up, and that is my actual center. Okay. So that wasn't so bad. Put the orange in there just for completeness. So that was the rotated position. Rotate around. That's where we know it is. Now we're going to go off and draw that. We know it's a 30mm radius. Just measure the 30 off this here. What can be seen? Well, if we look at this one, I can see the whole thing here in elevation. So that's nice and easy. Okay, and I can see some of it in plan. Of course, it's going to be tucked in underneath it here. So we'll just draw the other bit heavy. And we can just make some little hidden lines there. Hang on to the pin of the compass so it doesn't jump out at you when you do that. Okay, now we're doing good. 14.5 minutes in, we have all the part A done. Okay, again, showing the constructions and points of contact. So they wanted to figure out where the point of contact would be on these guys. Let's see where it is going to be. So my point of contact forgotten about that one, but we'll go back and pop it in very easily here. Okay, the point of contact will be on a line, a normal. Okay, so if this is a tangent to the orange edge, and normal is just going to, okay, there's the tangent, the normal is going to be perpendicular to it. So we just pop this in here. Okay, so there is my point of contact in the rotated one. All right, well, what are we going to do when we rotate that guy back? Okay, it's going to move across a little bit. My point of contact is going to move over like this as it rotates. Okay, it's going to go over somewhere in that direction. And where is it going to be? Well, it's going to be along this line. Okay, because that's where they're going to touch. So let's see what we can do here. Okay, so there was my original point of contact. Just bring it down very carefully. There it is. So that's the orange point of contact. And that just rotates with the whole diagram. So pop that over here. And that rotates around until it hits there. And of course the green point of contact is my real point of contact. And we just send that back up. There we go. And that right there, I'll give it a nice little green color, is my real point of contact. Okay, now what next? There we go. Always worth checking those little bits and seeing what we might have left out. Development of a conical surface A. Well, that's a nice standard kind of thing we do in our developments. Okay, so a cone is a slightly trickier one. What we're going to need to do is make it into a real cone. So we need to get the edge of the generator. So we're just going to extend this down to here and find out the total length of the edge. All right, it may or may not be at the actual center. That's just coincidental. So let's see where we're going to go. Now, we will take this guy here. It actually goes a little bit below the center. And I'm just going to do this in green so you can see where we're going. And there. So if it was a real cone, it would go all the way down to this point here. Now, that gives me my generator. A big one as well. So there we go. And that is the total edge. So, let's see where we're going to go. We'll stick it up here maybe. And there we are. Just making sure it roughly fits on the page. So we'll do a nice big arc like that. Okay. I think I might have gone off our page here, so we'll just move this a small bit so you can see that arc. All right. Now, a top tip, which I completely did not do, would have been to mark where the compass touched the page. Okay, now I can actually see it's there. But of course, if you do a little plus like that before you stick the compass in, it's much easier. You can always find the center. Okay, so we are going to take an arbitrary line to start it. I'm going to take this one because I definitely want to go any further this way. There we go. And it'll come around to some point over here, and I don't really care. It can go around for quite a lot. All right, well, how far around? So this is where we need to take the big end of the cone, which is this guy here. And we're going to take all of our little marks. Now it goes the whole way around. So we'll just come down here. Okay, take a 30-degree slice. And we're going to take this distance here to here. There to there. Okay, there's going to be 12 of them. I don't need to number them because they're all very even. So it's not like weird things happening at different ones. I just need to make sure I have the right amount of them. So I should see 12 panels. 1, 2, 3, 4, 5, 6. This actually isn't going to be particularly big because it's a very tall cone. That's 6, 7, 8, 9, 10, 11, and 12. So I'm just going to double check that I have my 12 panels. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Exactly for my 12 slices. So we'll put a construction line over here. Okay, so we're nearly there, except of course it's chopped off. So we need to figure out what we can do about that. Well, okay, and just give you a note, that distance from there to there was this distance here. Well, what we need is this distance before it's cut. So all we're going to do is we're going to take this distance here. Where are we going? From the center to where it's cut. So that's the bit of the cone that's removed. I'm going to pop it down here. There we have it. That's the missing bit. So now I'll just go back, go over this outer one heavy. And just heavy in the little edges, the bits we keep. All right, so that's the development of surface A. Okay, now the last little bit we need to do this one is actually not too bad at all. It's the development of the semicircular handle. Now this may seem a little bit weird, okay, but if it's just a semicircular handle, we straighten it out, it's just a long straight line. So let's do a little bit of construction over here. I'll just extend this one over. Okay, so it's somewhere, it's a line, all right. Well, if it was a semicircle, how big would it be? Well, we know now because it's 35 radius, okay, which actually is the same as this one. So we can use the same little measurement. Now, I meant to put that little measurement there is of course this measurement, all right, but it's going to be the same for our guy, all right. This is just going to be 6 panels. Okay, it's like we folded the handle down. Imagine the handle is sitting up like this. We're going to drop it down here, and we just take that distance along the edge. So, setting our compass to this, we just need 6 of these. So, and I'm going to be smarter this time and actually mark the beginning of it. Okay, make sure we're on camera here. Yep. 1, 2, 3, 4, 5, 6. So this was one of those slightly more unusual bits of the question, but it's actually dead easy when you stop and think about it. And that is the handle. Handle. And each of these little segments is just one section of our 35mm circle. So there we go. Lovely little drawing, nice few bits and pieces. Actually takes a lot of inspiration from DCG in the ideas it has here, and a lovely little glimpse as to how the circle method actually works.